Now example 6.7. A bob of mass m is suspended by a light string of length L. It is imparted a horizontal velocity at the lowest point A such that it completes a semicircular trajectory in the vertical plane, with the string becoming slack only on reaching the topmost point C. This is shown in figure. Obtain an expression for 1. V0, 2. The speed set point B and C. 3. The ratio of kinetic energies Kb to Kc at B and C. Comment on the nature of the trajectory of the bob after it reaches the point C. Okay, now see the situation given to you, that is like this. This is the lowermost position, suspended like this, string and a bob. Okay, so this particular position A, that we consider as reference position. Okay, so at reference position we take height of the object. When object itself is on the reference position, then height of object, that is 0. Now at this particular position to the bob we give some velocity. Now this particular velocity given to it V0 is such that when it reaches to the uppermost position C, then the string becomes slack. એટલે કે સ્ટ્રિંગમાં કોઈ ટેન્શન રહેતું નથી. બરોબર છે? એવી રીતે અહીંયા એ પહોંચે છે. હવે આપણે velocity given to bob at position A, V0, then when it reaches at C, so at C its velocity, and when it is passing through B, at that time the velocity at B. These three things we have to calculate, and then the ratio of the kinetic energies at B and C. Now we can solve this one as law of conservation of energy. Suppose first we consider the position A as the reference position, then at A, the mechanical energy at A, that is kinetic energy at A plus potential energy at A. But potential energy on the reference position itself, that is 0, because H is 0. So total mechanical energy, that is the kinetic energy. So we can write that is half mv0 square. Okay. Now at A, the required centripetal force, that is mv0 square by L, because this one is executing the circular motion on the circular path having radius equal to L. So mv0 square by L, that is the required centripetal. When it is at the lowermost position, two forces are acting: tension towards the center and weight mg downward. So net force towards the center, that is Ta minus mg, that is providing required centripetal force. આનો ક્યાંય use નથી, પણ required centripetal force towards the center એ આગળ ઉપર આપણે C point માટે લેવાનો છે, એટલે એ હોય એ ખાલી આપણે મેન્શન કર્યું છે એક. બરોબર છે? Now at position C, so when object reaches at C, then again at C, total mechanical energy EC equal to kinetic energy at C plus potential energy at C. Now at C we considered the velocity, that is suppose Vc. So kinetic energy, that is half mvc square. Potential energy, that is mg. Now with respect to the reference position, C point is at height equal to L plus L to L. So mgh, as per that equation here, we can write mg into 2l. When your bob reaches at C, the string becomes a slack. String માં કોઈ tension રહેતું નથી. So at position C, only one force is there, that is the weight that is towards the center. Clear? So the force which is towards the center, that will provide the required centripetal. So we can write mvc square by L, that is mg. Okay. So we can write vc square, that is gl. So vc equal to under root gl. One velocity at point C is now obtained. Then, now see here, half mvc square, substitute the value of vc square, that is gl here. Then plus this one, as it is 2mgl. So EC, that comes to 5 by 2 mgl, equation number 2. Now keep this one as it is. Now next step. We know, as per law of conservation of mechanical energy, total mechanical energy, that will remain constant. So mechanical energy at A and mechanical energy at C, that is same one. So mechanical energy at A, that is half mv0 square, equation number 1. And total mechanical energy at C here in equation number 2, we derived 5 by 2 mgl. So those two are compared. So half mv0 square equal to 5 by 2 mgl, mm cancelled, half cancelled. So v0 square, that is 5gl. So v0, that is under root 5gl. Means velocity at position A is also calculated. Now at position B, we want to find the velocity. Again, total mechanical energy at B, that is kinetic energy at B plus potential energy at B, that is equal to half mvb square, vb that is the velocity at B, plus mgl, because when the bob is at B, it is at height L with respect to the reference position. Okay. So we can write now EB, the total mechanical energy at B, and total mechanical energy at A will be same one. So EA equal to EB. EA, that is half mv0 square, equal to EB, this equation, half mvb square plus mgl. M will be cancelled from both the side. Then multiply this particular equation by 2. So half v0 square equal to half vb square plus gl. એ જે આગળનું ઇક્વેશન હતું એને આપણે અહીં ફરી લખ્યું બીજા પેજ ઉપર. હવે એને આપણે 2 થી મલ્ટીપ્લાય કર્યું. So v0 square equal to vb square plus 2gl. But v0 square, this v0 square equal to 5gl. v0 square equal to 5gl is substituted, equal to vb square plus 2gl. Make vb square as a subject, so 5gl minus 2gl. Therefore vb square equal to 3gl. So vb equal to under root 3gl. Okay. So now velocities at A, B and C all are calculated. Then after kinetic energy at B, so half mvb square. So vb square, that is 3gl, substitute here. Then kinetic energy at C, that is half mvc square. We already derived vc square, that is gl. So half mgl. Now take the ratio of kinetic energy at B to kinetic energy at C. So half m into 3gl upon half m into gl. So ratio will come to 3:1. Clear to all of you?